Hey guys, TornadoTwins here, and I wanted to make a quick video because recently for our video game we switched engines from Unity to Unreal. And if you're wondering, wait a minute, I thought you guys were Unity guys. Well, we are, and we still are. We've used Unity since 2009, but before that we've also used all kinds of other engines. You name the one out there, and we've probably used it. We've even built ourselves one last year for HTML5 and those type of things. So engines aren't really about the engine itself. It's what type of game are you making, and then you choose an engine that fits it. So in our case, we were switching over, and I want to show for this particular game, and I want to show you guys some of the core differences within the engines, so that if you're switching to one or the other, that you know kind of what the core differences are as a user. Because I have found very few tutorials on that, so I thought it'd be useful. Okay, so this is our game inside of Unity. So I'm going to play this here, and the game looks great. I mean, Unity does a great job rendering it. The character was walking through some grass. The water shader is really nice, and he can jump left and right. And obviously, this is what you'd expect from a 3D platformer to happen. Okay, so that's cool. So I'm gonna escape this out, and we'll switch back and forth between these two from time to time. So I'm switching to Unreal, and this is the same game inside of Unreal. Let me turn collision off here so we see it more clearly. And so if I play this game, this is pretty much the identical meshes that we have imported and exported over, and obviously the player doesn't have any textures yet, but these are all assets that I kind of got out of the box from other example projects and those type of things, even the water shader that you can steal from other projects. So yeah, this is the same game, but then within Unreal. The lighting is absolutely stunning because it's all physically based, and it's not really a fair comparison, I would say, because I was showing the other game in Unity 4, not in Unity 5, and Unity 5 is completely built around physically based shading, but that's what our game was built in. Okay, so cool. Let's take a look at some core differences here. First of all, scripting is very different. If I go into Unity and I'm gonna create like a new scene, I'm not gonna save this, and I'm gonna put a cube in here, so a 3D object and a cube, and I want to rotate that cube in script. Then I would add a script to it, so I'm gonna just create a folder here called delete me, and in there I'm gonna create a new JavaScript and call it rotate. And I'm just going to rotate the cube, and then I'm going to show you the difference in Unreal after that. So attach that to the cube, and then I'm going to launch my code editor, which is a separate program. It's also an important difference. In Unreal it's not. And then there I have a few options. First off, I have a start function, which is triggered when the game starts, and I have an update function which comes along every time the frame is rendered. Also, there is a on collision enter function which runs every time this object collides with something. But at this point, this object does not have any. Actually, it does have a collider on it, no physics. So that will run every time something triggers. And it's important that I'm mentioning these three because we'll see the same thing happen in Unreal in a little bit. So in the update function, I can rotate this cube, so I can go transform dot rotate, game object, of course, first, dot transform dot rotate, and then I have to give it a rotation vector, which is X, Y, and Z, to make it rotate. So I'm going to put vector 3, see if I can do this. I haven't done this in a while. 0, 1, and 0. Actually, 1 is very large because we're running this every frame, so I'm going to make it 0.1 and save this. See if this runs without errors. Okay, cool. So let's run this game here. Go back to my scene view and watch the cube rotate. No, where is it? There it is. Okay, so the cube is rotating. Great. So now we're going to do the same thing in Unreal. So I'm going to start a new scene here, a new level. Now this is pretty cool. When I make a new level, I can really make it empty, or I can have the atmosphere and like a base floor in there already, which is similar in Unity 5. So I'm going to choose that. Then it asks me, do you want to save the level that I'm currently working on? And I do. And it's also updating it in version control, which I'll talk about a little bit later, which is great for teamwork. So I'm here. I'm going to add a cube. Boom. I'm going to move the cube up. Now, by default, in Unreal, which is different than from Unity, an object is static, so it does not move. In Unity, I can also make an object static by hitting the static button up here, but it's not that by default. In Unreal, it is. So first I'm going to have to set that to movable. Then if I want to add script to it, I have to pretty much do that with this button here, say blueprint add script. And then it asks me where I want to save this object, because it's making it a prefab, similar to a prefab in Unity, but called a blueprint in Unreal. So I'm going to go to my blueprints here and interactables. I'm going to call this cube test. Alright, so create that blueprint right there. So here it is. I'm going to double click it, and now I have my cube in its own coordinate system, which is really nice, and I can change things about it. But I'm going to see that there are two types of script here. There's a construction script and an event graph. Now a construction script is similar to a script in Unity that you'd put in the editor folder, because it changes things inside of the editor. So this allows you to make interactable pieces, like a stairwell that automatically fills itself up based on the height you put in, those type of things. But this is really very similar to the script we just made in Unity. So there's a begin play, which is similar to the start function. There's an event actor overlap, which is similar to the onTrigger enter function when things are colliding with it. And there's an event tick, which is similar to the frame update function inside of Unity. Of course, using this is expensive because it runs every frame, but same case inside of Unity. So what we want to do is rotate this cube. So I'm going to right click here and see what we can do with the currently selected actor. And I've not actually done this before, so let's see if I can figure this out. As you can see, this is not scripting with text, but scripting with nodes, and I haven't believed in visual scripting for a long time, but actually Unreal makes it kind of fun. So let's go to utilities here and see if there's what we need. Here, transformation, found it. Okay, so local rotation. Yeah, we want to pretty much rotate it in local space. Okay, so here we have a node, and this node needs to be fired up by something that runs before it. So we're going to use that event tick and connect it to, and now boom, this has become less translucent, so it's actually active now. And then the rotation will rotate the blueprint itself, so the cube that the script is attached to, if you will. But we can also drag this out and then probably search for self. Yeah, get a reference to self. Okay, so this is pretty self-explanatory. And then we need a rotation vector similar to what we did in Unreal. Now, as you can see, there are three values here similar to, you know, X, Y, and Z in Unity, but X, Y, and Z is not the same in Unreal. Y is up in most 3D programs, but Unreal has been around a little bit longer, so Y is not up. I think Z is up actually in Unreal, but I'm not sure. Either way, you have roll, pitch, and yaw. Now, what's roll, pitch, and yaw? This is actually quite fun. If I pull out my browser here and I go to Google Images, then you'll notice that your roll, pitch, and yaw comes from the airplane industry, where, you know, pilots are taught how to rotate their plane. So if I zoom in on this picture here, you'll see that yaw would be the same as in Unity, rotating around the y-axis. Roll would be, you know, around the z-axis, and then x. One simple way to remember this is what I kind of do for myself is pitch is obviously easy, because pitch, you always pitch something up or down. So pitch makes the nose turn up or down, similar in audio when you pitch audio up and down. Roll is easy because every morning you roll out of bed and you kind of roll over sideways. It's a pretty easy way to remember this. And yaw, as the way I remember it, it's kind of corny, but it works. If somebody calls your name, you turn your head and say yaw, you know. Yes, you can laugh now, but it pretty much turns the head of the object. So we want to rotate things by yaw in this example. So I'm going to do that, yaw, and set that to 1, for example. Here we go, and I'm going to compile this and save this. In Unity, you only have to save it, and as soon as you Alt-Tab or Command-Tab over to Unity, it compiles it by itself. Here you have to actually hit the compile button, which is a little bit tedious, but I get it. Okay, so then we're gonna go into the game here, hit play, and as you can see, the cube now rotates. One other fun thing is that the player starts on the player start node inside of the engine, so I don't really have to put a player prefab in my game ever, which is cool. Okay, so that's the same. Now let's talk about some more differences here. The materials and shading is very different inside of Unreal, and I've always steered clear of shader programming because it's just not me. I'm not good at it. I'm not a technical artist, but in Unreal it's actually quite fun, and it taught me a lot about how shaders work. So if I go to my material folder and make a new material here, I'm gonna right click and say new material. I'm gonna just call it delete me, and then I open it up. Then I have another node editor, which is you know, similar to the nodes in Blueprint scripting, but of course has very different functionality. And it gives me all kinds of items here that I can use. Now base color is same as the diffuse in Unity. So if I added a texture in here, or if I search for texture coordinates, actually I think I'm going to use a parameter. Here we go. Yeah, so I'm going to use a texture sampler parameter 2D. I'm going to drop that in. I'm going to give that a name, texture. And as you can see, it already loaded a default texture that I can change over using my drop down here to any other different texture. So if I wanted to make, for example, dirt, I'm going to search for that and use that. Then I connect that node to my base color, and boom, now have a simple dirt texture. However, it has a lot of specular on it by default, so if I wanted to turn that off, I can use that. I can pretty much set specular to 0. So I'm going to do that and type in constant. If I can spell constant, and a constant is pretty much a variable. I'm going to set that to 0, push that into the specular, and boom, now there is no specular on this dirt. Then in Unity you can add tiling to your texture, and if I want to do that, I have to mess with these UVs here. So if I go and type in coordinates and grab a texture coordinate variable, then I can push that sucker in here and actually play with the U and the V. So if I wanted to tile that 6 times, like, you know, like I would in Unity, then you see the texture is now tiled many more times. Now of course I can add a normal map to that as well. So if I copy and paste this node and instead use a normal map, dirt, and I'm using the ground dirt here, I of course have to use the same UVs and then connect that to my normal. Then now I would have sort of what would be your default diffuse shader inside of Unity. Now there are some really cool other pieces in here, which is you know, roughness, which is how smooth or rugged the surface is. So smooth really makes it reflective or not, and metallic, which makes it, you know, emit like metal, and then emissive, which makes it light up. Very cool shaders in there, but we'll get to that at some other point. So I also made some shaders in here that are very similar to how Unity works. This is my Unity shader, if you will, and you can steal this if you'd like. It's a little too deep to explain right now. It's actually quite simple, but you still have the same items in here. We have our normal map and we have our texture driven by our texture coordinates, but then also I'm multiplying it by the tiling coordinate, as well as a diffuse color. Like you have in Unity, you have a little color picker that changes pretty much the way things look. And so what I can do with that Unity shader is, if I go back into my project, I don't want to save this, and I make a clone of this, so I right click and I say create an instance, and I can give it a name, delete me. And with that instance, if I double click that, it looks very different because it's an instance of a material. You can't change the values about it except the variables that I have exposed. So here, if I enable the diffuse map and diffuse normal map, I can overwrite this with other textures. And if I overwrite my diffuse color, then I have a color picker that pretty much colors the material different colors, same as you would expect it to work inside of Unity. So these are a couple of different things between the engines. Lastly, I want to talk about real quick about team collaboration with your team, and this is something I'm very excited about. You know, when we were running our team, our people are all over the world, and so we have to push big files all over the world. And Unity has a nice feature where it gives every file inside of the system a meta file, and I can show you that here. So if I reveal this in Finder, you'll see that there's a meta file, which is a text-based file, which is very nice because it has its own unique ID and those type of things, and that's how the engine keeps track of links between files. And this is nice because you can push that into GitHub, and GitHub will know that this, it will have the same meta file in somebody else's project. Because in Unreal, it actually hooks up with source control. So if I click on this and I say change my source control settings, and I can see that I have different version controls that I can use. So I can use SVN, I can use Perforce, which is kind of the industry standard, and I can use Git, which includes GitHub. Now GitHub is not my favorite anymore, since it kind of gets really slow when you're using projects over a gig, and they actually advise against it. So a game project gets over a gig very quickly. So we're using Perforce now. Now in Perforce you can set up your own workspace, and then with that workspace pretty much make your changes, and then when you're done, it pushes it back to the repository inside of Unreal. So if I accept these settings, I have changed a lot of files here. I've made all these these shaders, these delete me's and whatnot. So if I go to source control and I say check out modified files, it's pretty much going to take these files and check them out like you would check them out in a library. So you're saying I'm renting this book right now, nobody else can touch it. So I'm doing that. I'm going to check it out. And it wants me to save the level. I'm not going to do that right now. So because this level is just junk. So what I can do with all the changes that I've made, I can click here and say submit back to source control, and it will upload all the files that I've changed back to source control. And that's really nice because I never have to leave the editor. I can also right click any folder and say sync, and it downloads everything that's new, those kind of things. Or I can mark new files for addition. Then as soon as I push everything to source control, it adds all those files that are marked for addition from within the engine. So that is really cool. So that really concludes our little look into the differences between the engines. If you have any questions or you want me to cover something else, hit me up. Alright, talk to you later. Bye bye.